Now, in the last lesson, we've somewhat created our front end with just HTML and CSS. And also, we've got our Motoko code, which is pretty much all set up. Now we just need that bridge in between the two of them, which is our index.js, the JavaScript code that's going to tell the front end how it should interact with the backend. So the first thing we need to do is we need to be able to expose the important parts of this Motoko code to our index.js. And to do that, we have to import the dbank module. So what I'm going to say is import, and then we're going to add the curly braces. Inside here, we're going to add the name of our module, which is our dbank. And then we're going to specify where this should be imported from. Now I'm going to use a relative path. If you're not sure about relative and absolute paths, head back a few modules. We talked about this in more detail. But we're going to go into the declarations folder, which is right here. And we're going to tap into the dbank folder. And the files inside the declarations basically just exposes our Motoko code to our JavaScript in a way that our JavaScript code is able to understand and is able to access and call these functions. So it kind of just functions as a bridge between the two languages. And then we're able to call and use these functions like check balance, compound, top up, and withdraw. So what do we want to address first on our front end? Well, I'd love to be able to update this line so that it's not just a placeholder text, to actually show the current balance. To do that, I'm going to tap into this query function, which is the check balance. And this should be able to happen pretty quickly, and it should be able to return us the current value. So I want this balance to be updated every time this page loads. That means we're going to have to add in an event listener in JavaScript to listen for when the page has loaded. So let's tap into our window object, add event listener, and the name of the event listener is load. And this is basically going to get called when all the code on the page has finished loading up. And when it has finished, then it's going to call a callback function. And this function is going to do something. So let's just go ahead and do a console log. All right, so that's a pretty simple bit of JavaScript code. Let's go ahead and test it out. So if we bring up our console, and make sure you're in the console tab, and then let's go ahead and reload the page. You can see it says finish loading. So that's working, and that's great. Now let's go ahead and comment that out. Now, instead of finish loading, what I want to do is I want to be able to update this span here. So instead of having the value of 234, I want to change it to say, well, whatever is the value of our current value here. So to do that, let's go ahead and create a constant, and I'll call that the current amount, and we'll set that equal to the dbank dot check balance result. So basically, once we've checked the balance, we're going to assign it to this current amount, and then we're going to use the document.getElementById, and then use getElementById to grab hold of that span, which has the ID of value, which you can see right here. And then once we got hold of it, then we can change its inner text to be equal to whatever is the current amount. So let's go ahead and hit save and test this out. And you can see once you refresh that we've got something called an object promise here. So what's happening here? It's obviously not doing what we want it to. Well, the reason is because the current value is returned asynchronously. So that means we're not actually waiting for this result to come back, and instead there is a promised object which can return at any point depending on how long it takes to query the blockchain. So what we have to do instead here is we have to turn this also into an asynchronous function so that we can adapt. And we have to make this method call have the await keyword in front so that we basically wait for the result to come back and then asynchronously update our element with the current amount once it does return. So let's hit save and let's refresh, and you can see our current balance now shows up. Now this is quite a few digits after the decimal place, and it kind of is a bit too much and it clutters up the screen. What we want is to reduce it or round it to have only 2 decimal place accuracy. If you can't remember how to do this using JavaScript, then it might be a good time to have a look at the documentation or have a quick Google search on Stack Overflow. But I'm going to set this as a small challenge for you. See if you can figure out how to modify the code here so that instead of having all of these decimal places afterwards, we only have 2 decimal place accuracy. Pause the video and give that challenge a go. With JavaScript, we have this very helpful function called math.round, and that means we can round our current amount. Now, if we want to round it to 2 decimal places, the easiest way is to simply multiply the current amount by 100, round it so that there's no decimal places, and then afterwards, once that's done, just simply divide it by 100 again. And now you can see it update, and we now have 2 decimal place accuracy. Perfect, exactly what we want. Now that we've gotten this part sorted, the next thing to do is to listen for when the user finalizes their transaction after typing in either an amount to top up or an amount to withdraw, and then trigger the corresponding top up or withdraw, a bit of a typo here, functions inside our main.mo. So let's go back to our index.js, and we need to add an event listener to this form here that we've got in our HTML. The form has a input at the very end, which has the type of submit. So we can actually listen for that event on this form. Let's go ahead and get hold of the form. So we can say document.query selector. And this allows us to select an item inside our DOM. And in this case, I'm just going to get hold of the form. So remember that with query selector, you can use the # for IDs, the dot for class. And if you're trying to query for a HTML element, then all you have to do is just give its name. So it's the same as how CSS selection works. Once we've gotten hold of our form, let's go ahead and call add event listener so that we listen on this element. And then we're going to listen for the event, which is called submit. Basically, this is going to be triggered when that submit button here gets tapped. And once that happens, then we have to describe what should happen. So we're going to create another async function. And this function is going to let us know what event triggered it. And inside this callback, let's first start out with a console log so that we can just make sure that it's actually getting triggered when the submit button is pressed. So now let's hit save, and then we can go back and add an amount to top up or an amount to withdraw, and click on a button, and you can see it says submitted. Although sometimes it shows submitted very quickly and then it kind of just disappears. So that is because with forms, there's a default action, which is to actually clear the form and submit the values. Now, if we want to remove that default action, then we can actually get hold of this event. So the event of submit, and then we can call prevent default on that. So if we hit save again, and let's go ahead and do that, you can see now it doesn't actually clear any of our fields, and we always see this submitted down here, and it doesn't reload the page and get rid of it. Let's comment this console log out. The next step is to actually get hold of what the user typed in here or in here. Let's create a new const, and I'll call that input amount, and I'll set it equal to whatever is inside that field, which is going to be document.getElementById, and the ID of it is input amount. and then let's get hold of its value. Now let's do the same thing to the withdrawal amount, but for simplicity's sake, I'm just going to call it the output amount because I seem to keep making typos on the withdrawal. So again, get element by ID, and I'm going to go ahead and copy this ID over so I don't make any typos in it. And then let's get hold of its value as well. So now that we've got what the user typed in to the input amount or the output amount, the next step is to actually use this to top up or withdraw from our funds in the main.mo. So we basically want to trigger this function first, right? Now let's try it out. Let's simply do what we did before, which is to use the await keyword, and then we tap into the dbank and we call this top up function. This top up function expects an input, and the amount is going to be the input amount, whatever the user typed in here. Now, if we go ahead and hit save and try to run this code, you'll see that we get an error. And the error says invalid float64 argument, and then it points to this number 10 that we added in here. So what's happening? Well, do you remember I said when we imported our dbank DID from the declarations, it basically tells our JavaScript file which functions are available in our main.mo and how to call it. Now, in this case, the top-up function expects an input that has a data type of a 64-bit floating point number, because that's what we've got right here. But at the moment, the values that come out of an input with type number is by default a integer. So we have to convert this into a floating point number. And you can see that actually for these inputs, I've already added the step amount, which means that you can actually enter a value with up to 2 decimal places of accuracy. Now you can add more numbers afterwards in the input, but once it actually comes through, the value will just be accurate to 2 decimal places. So this input actually allows for floating point numbers to be entered. But in order to convert it into an actual floating point number, we have to use the method parseFloat. And it will parse this value into a floating point number. And while we're at it, let's go ahead and do the same for the output value as well. So now if we hit save and we try this out again, you can see that we no longer get any errors. Click finalize transaction. Looks like nothing's happening, but all errors have gone away and it's actually behind the scenes done what we want. So in order to view what we've got, well, we actually have to do what is in these lines of code, right? We have to check balance and update that span again. So for now, I'm just going to copy and paste those 2 lines right here, hit save, go back to my website, and let's try it out. Let's top it up by $10. So at the moment we're on 1446, click finalize transaction, and that jumps to 1456. So perfect, it's actually working. Now, one of the problems you might notice with our current code is when we type an amount to top up and we click on this button, it looks like as if nothing is happening, but then it actually does work behind the scenes. So remember what we said about these update functions in the ICP taking a little bit of time. So it can take anywhere between 2 to 3 seconds. And we don't want the user to look at this front end and think that nothing's happening, because they'll try and click this button lots of times, which is going to really mess up our backend. So let's give them some clues. So one of the things that we can do is as soon as they click the button submit, we can actually disable that button. So we can tap into our button. So let's create a new constant for it, and we'll get hold of the event dot target, and we'll add the query selector. So basically this is going to get hold of the form that we've got that we're listening to when it clicks submit, and then we're going to query for the selector, which is our submit button. And our submit button handily has an ID called submit button. So let's go ahead and add that selector in there with the pound sign to select it. And this is going to be our button. So then as soon as basically the user types in the input, we can tap into our button and basically say set attribute. And we can set the disabled attribute, which you have, to true. And then once we've done the top up and we've gotten hold of the actual new balance, then we can go ahead and tap into that button again. And instead of using set attribute, we can use the remove attribute function. And we're going to again tap into the disabled attribute, and we're basically just going to remove it. Because if you try to set the attribute to false, it's actually not going to work. And this is because an element becomes disabled if the disabled attribute is set. So it doesn't actually matter what its value is. It could be true or it could be false. It does the same thing. The element basically just gets disabled. So we have to remove it completely instead. Let's hit save on our code. Let's try it again, refresh, add our $10, click finalize transaction, and you can see I've added some separate CSS to basically tell the user when it is that you can't interact with it. And as soon as this updates and we're back to being able to top up or withdraw, the button comes back online. Now, one last thing that would be nice is to actually remove this value once it's actually done, right? So to do that, we can tap into our document, get element by ID, and then grab hold of our input amount, which is the first input. And then we can set the value to basically just an empty string. So now if we try this again, when I click top up, my button gets disabled, and then once it's back online, the input gets cleared as well. So we're ready for the next step. So I think in terms of user experience wise, this is a lot better than what we had before. So now that we've done the top up part, the natural thing that comes next is of course the withdrawal. Now, there's just one problem that we have to tackle before we do that. How does the code know that we're trying to top up or we're trying to withdraw? Because right now the code is going to be carried out every single time the submit button gets pressed on the form. So if we leave this empty and we don't type anything in there and we click finalize transaction, you can see that it not only messes with our current balance, but in our debug, we can see that it's printing NaN, which comes from this debug print showing us the current value. So what's actually going on here? If we don't actually add any value to an input, it still has a value. It's not a number value. And if we pass that around to our backend, then it's going to mess everything up. So we need to basically add some sort of condition, right? We need to make sure that we only top up when the user has typed something in here, and we only withdraw when the user has typed something in here. So we can check that by using an if statement. We can say if the document dot get element by ID, and we type in the ID of that input amount. So remember, it's the input and it has an ID of input amount. Put that in here, and then we get hold of its value, and then we check the length of that value. Because if it's an NaN, the length will be equal to 0. But if it so happens that in this case it's not equal to 0, then that means the user has basically typed something in that field. So then we can safely call our top up function. So now if we hit save and we leave this empty and we click finalize transaction, then we're not going to have any problems. Now, in the process of showing you the problems around input validation, I've actually screwed up the data stored on my canister. So what I'm going to do is reset the data on my backend to how we had it in the beginning. Current value should equal 300. So let's go ahead and uncomment these two lines of code, reset everything to the beginning, And then let's go ahead and add a debug print statement down here just to make sure that the current value is in fact being reset, because with the orthogonal persistence, sometimes if there isn't enough of a change in your code and you hit deploy, then it doesn't actually update these stable variables. So I'm going to save this file, and then I'm going to end all of these processes with a Control-C. So this is the NPM, this is the simulated ICP. So now that both of them are ended, let's spin everything up again. So dfx start over here, and then over here we'll do the dfx deploy to make sure that this new code gets updated, and we reset the current value to 300. And then once all of that done, we can again use our npm start to spin up our server. And now if we come back, you can see our current balance is being set back to $300. And now if we try the same thing again, so leaving nothing inside the amount to top up box, click on finalize transaction, you can see that instead of getting NAN, it actually just doesn't trigger that line, which breaks our code, which is the top up by some sort of non-value, because the length is basically equal to 0. So now that we've figured out how to do this part and making sure that it actually works, then it's time for you to create the other part, which is the withdraw component. So see if you can get the output amount that's typed in to here to be subtracted from the current balance using the function that we've got in here, which is called withdraw. Now, it's really easy to make typos with this word, and I've done it so many times. So just be careful with it. And whenever you need an ID or a function name, it's actually easier to just copy and paste it. That way you don't make a lot of typos like I do and you don't have weird errors that you have to debug. So pause the video and make the withdraw component work. All right, so again, we're going to need an if statement. Because these are two completely separate conditions, I'm just going to split out another if statement, rather use an else if, because the logic seems a bit clearer to me. But it doesn't matter if you use an else if, as long as you didn't use an else, because that's only going to check that the input amount is in fact equal to 0. So in this case, we're going to tap into the document.getElementById, and then the ID in this case is equal to withdraw amount. So I'm just going to copy and paste that in here, get hold of its value dot length, and check that is not equal to 0. So make sure that they typed something in there. And then we're again going to use the await keyword to call our withdraw function. And we're going to add the output amount as the input to this function. Now, once that's done, our code is already going to get hold of the new balance and update that span. So the final thing we have to do is just to clear that input. So document get element by ID, and then again put the withdrawal amount input, set its value back to an empty string. So now let's test it out. We can top up by $10 and we can withdraw by $10, and it's all working as expected. Now the final thing I want to add is to compound my value by the interest. So we'll just tap into that compound function down here after either this if statement carries out or this one. But either way, once the user adds some money or takes some money away, we're going to compound the value. And if we go back over here, hit refresh, now you'll see that every time I top up, it's going to compound. And because a lot of time has passed, the current balance is absolutely massive, which means we can go back over here and reset the current value and start time. So to force this to reset, we have to first, if your code in main.mo has the current value and start time not commented out, you'll have to comment it out and then run deploy. And once that's been deployed and updated, then you can come back and uncomment these two lines of code, hit save, and run dfx deploy again, just so that we force this to be reset to 300. And you can see in the print statement, we're back on $300. So now let's go back to our front end. And if we top up by 10, you can see the current balance will be slightly more than 310. And if we withdraw by 10 again, you can see that we're adding a little bit of compound interest each time. So that's pretty neat. Now, one last thing before we finish off this index.js is it would be nice to be able to take out this repeated line of code, because it's right here and it's also at the top here. So I'm just going to create a async function. And we'll just call it update. So now we can simply just call update right here. And also up here, we can delete these lines of code and instead just call update as well. Cool. And just to check and make sure that it still works, you can see the amount being added and also a whole bunch more from the interest. So our current balance is growing really quickly. Now, in reality, of course, it would be pretty crazy to have a 1% interest every second. But because we're working with this over a short period of time, I wanted you to be able to see it easily. So there you have it. We finished hooking up our ICP backend with our JavaScript frontend, and we've managed to get everything that we've implemented in Motoko to be accessible to the user through the frontend with HTML, CSS, and JavaScript. Now, there were quite a few points in this lesson where potential errors could have occurred. So if you head over to the next lesson, I've pointed out some of these potential issues. But if everything went fine, then feel free to skip the next lesson, and I will see you back here where we learn how to deploy this onto the live internet computer blockchain.